Hey Sylva, how's it going? I will try and make this as loud as possible. Um, First of all, I should be yelling at you because we did all these things before you left and you weren't paying attention, but that's okay, man. I still got you covered. All right, so I kind of rewrote this problem. You had two problems here. They had to do with quadratics. We did this as projectile motion in like, I don't know, December, January, I think. Okay. But they want to find your domain, your range, your axis symmetry, your vertex, your maximum or minimum. We can answer a couple of these questions just by looking at your function or your equation right here. First of all, you'll notice that this is negative out front. Negative means that it's going to be shaped like this. So we can say for sure this is going to have a maximum, right? It's going to go down for as far as you want. It's never going to stop going down. But again, as we come up, we're going 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 up. We're stopping at a maximum, and then we're going down, 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 down. Okay? So again, you see a negative number, it's going to be shaped like this. Again, like to treat you guys like little kids, but if it's if it's a negative, it should be a sad face, you know. Had this number out here been positive, had this just been something like this, 1/2 x squared plus 6, right? If it was positive, then it would have a minimum, right? It would come up to infinity, right? But it would go down, 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 minimum, and go up, 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 up. Okay? So again, you can tell that just from look. Oh my God, you can tell that just from looking at it. But once you graph it, you're going to see that anyway. I just want to say for the record, they were nice. They gave you these numbers, what your inputs are, right? So we talked about this as functions, right? These are inputs. You're going to plug these numbers in for x. We're going to see what our outputs are, okay? You'll notice, I don't know if you remember, this has no b term. So this is negative 1/2 x squared plus 6. There is no b term, right? Normally we say something times x squared plus something times x, like b times x, plus some constant at the end. So you have an ax, right? And you have a c, you have no bx. So that also tells us something about the graph, and I'll explain that to you as we do it, all right? So let's do it, all right? So they want you to plug in -6. If you notice, they gave you all even numbers here for your x values, for your inputs. They give you all even numbers because you're going to have to multiply times 1/2. So when we take the half of even numbers, we get nice even. We get nice integers out. Okay. So the first one, we're plugging in -6. So I don't necessarily want to write all these out. 1/2 times -6 squared plus 6. -6 squared is 36. Right. -1/2 of 36 is going to be -18. -18 plus 6 is going to be -12. Okay.
Happy birthday, sir.
All right. So we're going to plug in -4. -1/2 times -4 squared plus 6. -4 squared is going to be positive 16. 16 times -1/2 is going to be -8. -8 plus 6 is going to be -2. All right. I'm going to plug in -2. -1/2 times -2 squared. Well, -2 squared is going to be positive 4. -1/2 of 4 is going to be -2. -2 plus 6 is going to be positive 4. Okay. You're plugging in 0. You're getting out 6. I know that one for sure. Whenever you plug in 0, this is what comes out. So that's going to be your free point right there. Okay. Over here, -1/2 times 2 squared plus 6. Well, 2 squared is 4. -1/2 is -2. -2 plus 6 is going to be positive 4. Guess what? We found our vertex, right? Look, I went 4, 6, 4, right? I bounced back, right? So like now, if I keep plugging these numbers in, you're going to see that I'm going to get out the same thing, right? 4 squared is 16. -1/2, 16 is -8. -8 plus 6 is going to be -2, right? So again, now we've got that symmetry we were looking for, and if you plug in 6, you're going to get out -12. So I'll kind of erase all this just to leave the numbers here so you can see that we've got that symmetry we were looking for, okay? Now, before I mentioned, this one has no b term, right? So it has no b term. What happens in those cases is that 0 6, that's always good. Well, not 0, 6, but 0 is always going to be the input that gives you your output. So let me just move these over here. Oh my God. Should have just rewritten them. Okay. So again, if there's no b term, right? But we said ax squared plus bx plus c, right? There's no b term. There's nothing times x in the middle, right? Your blank spot right here. Again, that means 0 is going to be your axis of symmetry. You're going to plug in 0. This is going to be both your y-intercept and your vertex. Okay, so let's go ahead. Let's graph it. I can't graph negative 12, so maybe I'll probably move this graph up a little bit. I've got negative 1, 2, 3, 4, 5, 6, and I should probably be down here negative 12. Negative 1, 2, 3, 4. Negative 1, 2. Negative 1, 2, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6, and then we're coming down the other side. Okay. I don't know. Something like that. Okay. Nice and round. Okay. Yeah, don't draw straight lines, but again, your graph should look something like that. And again, what do we say? Maximum, like we expect, right? There's a maximum. This goes up, 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 up. Maximum. Down, 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 down. Right? There is no minimum, right? It just keeps going forever, right? So it never actually reaches the bottom. Right? So let's talk about it. What's your domain? What's your range? Your axis symmetry? Well, let's get the big ones out of the way that we know straight from the graph. Okay. Your vertex is right here, right? Your vertex is 0, 6. Okay. Your minimum maximum is going to be a maximum. Okay. Your axis of symmetry. Okay. Your axis of symmetry, there's a formula for axis of symmetry, which I can go over if we need to. But again, what are you looking for is where you can just kind of split this graph down the middle. Your axis of symmetry is right here, right? Easiest thing to say about your axis of symmetry is it is your x coordinate, okay? So in this case, you can say x is equal to 0, okay? This is the line x is equal to 0, okay? So again, there is a formula for that. You don't necessarily need to use it here. If you got questions about that, I will gladly answer them. Okay? All right, now your domain and your range. Okay, so let me get some of this other stuff out of the way. Okay, so your domain is all your x values that give you an answer, right? So let's think about this for a second. Your domain is your x values that give an answer. Well, in this case, every x value you plug into this function gives you an answer, right? Right, everything. There is nothing you can't plug in. There's no value x that you can't plug in. You can plug in decimals, you can plug in fractions, you can plug in positive numbers, you can plug in negative numbers, you can plug in 0, you can plug in irrational numbers. Everything is going to give you an answer, right? Right? Like if I plug in negative 10, somewhere down there there's an answer. Negative 9, negative 8, somewhere there's an answer, right? And then here we actually have these answers graphed. All these x values, right? Every x value has some output, right? These are all going to give you, every x value I plug in is going to have a corresponding y value, okay? So, again, talk to your teacher about how he or she wants us to explain. Your domain, there's a lot of ways to say everything, right? So everything. So we could say that your domain goes from negative infinity to positive infinity. We call that interval notation, okay? We could say set builder notation, the set of x such that x is greater than and less than something. So throw x in the middle. What's x greater than? Negative infinity. What's x less than? Positive infinity. Right? Everything's an answer. Or if you want to get real fancy, you could say, I believe it's the set of x such that x equals all real numbers. Give you some fancy block letter R in there. That's terrible. Okay. Something like that. Okay, fancy block letter R. I don't know what your teacher wants. That's really up to them. I would be okay with any of these personally, however you want to write it, okay? But the big thing is it's all numbers, right? Everything, right? If you wrote it out in words to me as a teacher, if you said, every number, all numbers, right? All real numbers, okay? That would be fine too, okay? Your range, on the other hand, is a little bit trickier because your range only goes so high, right? So look, my y values, okay, I got 2, right? I got y values. I got y values. Oh, but the walls are closing in, aren't they? Right? They're getting, right? I got y values, always got y values, always got y values, always got y values, until I get to my maximum, right? Here's where my y values stop. There are no y values up here, right? We really have this kind of line of demarcation right here, right? This is where the y values stop, okay? So we need a way to express this. Let me get all this stuff out of the way. All right, so, well, your y values, again, your domain is your x values, your range is your y values, okay? We could say it goes from a negative infinity, right? So these are all going to start the same, a set of y such that, right, y is between, right? Again, these I always tell my kids a lot of people have a hard time with interval notation and sepal notation rather. Always start like this. You know you're talking about y values because it's range, right? Y is going to be bigger than something. Y is going to be smaller than something. Draw your fancy squiggly lines, okay? Okay. So, what does y got to be greater than? Y is got to be greater than negative infinity, right? Always, oh, by the way, with infinity, you're always going to have the soft bracket. You're always going to have the greater than or less than sign. Never an or equal to, right? You can't be equal to infinity or negative infinity. In this case, however, though, you do have a maximum. Your maximum is 6. It stops at 6, and it includes 6. It includes 6. So what are we going to say? It goes from infinity to 6. You have to put the hard bracket there. Hard bracket says we're including 6 in our answer set, okay? So y is going to be less than 6, and what are you going to do? You can put the or equal to sign, all right? So if you have a hard time expressing domain and range, let me know about that. I can explain that to you both together, okay? All right, and we're on that time. All right, so the other question. Determine the value of c by using the graph, okay? Now remember, your function form for quadratics, ax squared plus bx plus c. Your c value is always going to be your y-intercept. That was the same when, remember we did these back in the day, y equals mx plus b, right? The number at the end was your y-intercept. Still the same thing here, right? Whatever constant you have at the end is going to be your y-intercept, okay? We call that your free point when we were graphing. That's your free point right here, right? So if you notice for this one, yeah, it was, it was y is equal to negative 1/2 x squared plus 6, right? Plus 6. Plus 6, right? Your y-intercept, 6, right? Okay? So 0 and whatever that term is right there, right? So if we go back to this one, I said, hey, what's the value of c? It's right there. It's 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. Make sure you throw that negative sign in there, right? So whatever this is, whether this function be ax squared plus bx minus 8. Okay, and there's some other things we can figure out about that as well. Okay? All right. Other question is, over what interval is this function decreasing? Okay, so again, we're going to have to use some secular notation. Now, your function is decreasing. It's going down, 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 down. Stop. Up, 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 up. Right? Okay? So it's decreasing. It's decreasing between here, right, and negative infinity, right? Negative infinity all the way up until you get to your vertex, right? At your vertex, it's not increasing, it's not decreasing, okay? Right, at your vertex, it's flat, it has stopped, right? So you would say this function is decreasing from negative infinity to negative 1, okay? What I would not do is I would not include negative 1. It's not actually decreasing at negative 1. So I would probably say it's decreasing from negative 8 to negative 1. Okay? Okay? It's increasing from 1 to infinity, right? But I'm sorry, from negative 1 to infinity. Right? From here it's increasing, right? But at one itself is not increasing or decreasing. Double checking your teacher about what he or she wants with your answer there, okay? Listen, man, I do thank you for sending me some questions. I always love keeping up with you guys and making sure you guys are doing right, okay? Do me a favor next time. I know you got these problems due when they're due and whatnot. I check my email first thing in the morning and when I leave for the day. So if you send me an email at 4 o'clock, I don't get it until I get to work, okay? I will say this, though. I do get to work excessively early in the morning, right? I've already been here for close to an hour, okay? So, listen, you got questions, send them in. It's good to talk to you.